I hope you liked that little introduction to tonight. That was a spontaneous tour of the Earth and Moon through the auroras and through some of the craters on the Moon. Really exciting. This is an interesting product. We've used this before with SkyTour LiveStream, but now it's the first time we're actually going to do an established tour of the solar system. And I had seen, you guys didn't see this before, those that just arrived, but this is how it came up. We're gonna go land on Pluto. We're gonna land on Neptune's moons. We're gonna look at distant asteroids. We're gonna go out in the Kuiper belt and land on some of the asteroids that are out there, the icy bodies, and we're gonna actually see what it would look like right from there. So I want to say hello to all of you who've joined us tonight, and thank you for coming out. This is gonna be a fun night. Now, there's not too many of you here, but you know what? The people that matter are here, and that's cool. So, without further ado, we're going to leave the Earth and the Moon behind, and we're going to head on out to the first planet in our solar system. We're going to go to Mercury. All right, and that's easy to do, because there we go. There it is out there. You'd never know it from a star until you actually started going toward it. Alright. Right now we're just about 1 AU from it. And we're going to go around it and then circle back so we don't have the sun in our eyes. Mercury doesn't have any moons. And it's somewhat tidally locked to the sun. So as we get closer to it, we'll actually see how it actually looks. And let's see now if we move closer. Oh, that's kind of cool Mercury music. Yeah, oh, sorry. Let me get us back to our generic screen. Apparently I left that off. Sorry about that. So yeah, so we're moving toward Mercury now. We're going at a leisurely 4,400, 7,000.07 times the speed of light. And you can see that not much is happening, although in the upper left you can see how close we're getting. We're cranking away the kilometers as we get closer. And when we get up to about half the speed of light, you can start to notice some movement there. Okay, but we go even higher, and we'll close in on Mercury. It's the first planet. It's closest to the sun, and when you look at it, you can tell which way the sun's going, can't you? It's over here on the left. Now let's get it closer here. Let's move it in. We'll be able to land on Mercury too, you know. Yes, we will. Yeah. Hey, what the heck? Where'd it go? Okay, hold on. Don't know why that keeps going away. Should not be doing that. You might notice the Pleiades right here and the Hyades. This product has every star in the right place. And this is Gumby over here. You can see Gumby. And here we are. Here we are at Mercury. Yes, sir. And Mercury is inhospitable, to say the least. Oh, yes. We could never survive there. Temperatures that would melt lead. Okay. So for a space probe, we can figure that we might be able to cruise to Mercury. We did. Okay, and we're gonna just circle over the planet here. We slow down as we get into orbit here. Oh yeah. And these are accurate, by the way. Mercury looks just like this. These craters are all named. That was the Andromeda Galaxy up there that we just saw. There it is again. And I will tell you, we zoom around here. Take a look at Mercury here. Wow. I'm Gumby, damn it. That's right. Mercury looks like the moon for the same reason the moon looks like the moon. There was a bombardment era in our early solar system's history, and lots of craters. You can see rays coming out from these craters, much like the moon. Again, for the same reason. Mercury was a tortured soul, let me tell you. That's right, Gumby's mission control, Charles. So tell me, how are you doing? I'm glad you're here. You survived Thanksgiving. That's good. Oh, yeah. Mercury's temperatures are really hot on the surface, hot enough that lead would boil. But, you know, it's true that good things come in small packages, and Mercury has taught us a lot about our history and how we formed by looking at it. If only we could cruise by Mercury at this kind of speed. I mean, we're actually moving at about 700 kilometers per second right now. Yeah, and we'll see the sun come in here in just a moment. Yeah, you can tell the sun's coming because we're heading behind Mercury, and the shadow will be here soon. You know what's interesting? And I know you guys know this. Our solar system has such beauty. Such tremendous beauty. And as the sun gets eclipsed by the limb of Mercury, we see nothing but blackness. But we know it's there. We know Mercury's there. Hidden in the murk, we have Mercury. And sometimes early in the morning or just at sunset, you can see Mercury just next to the sun in the sky. And it will typically look like this. It'll be a little crescent, kind of like a tiny Venus. Really nice. So that's Mercury. I think now we should go to the planet that used to be considered a sister planet, and that was Venus. Of course, it was never a sister planet. It was really, really way too hot to ever be considered a sister planet of ours. But they, you know, in the early days, before we knew anything about it, it was considered a sister planet to us, and it's not, of course. But we're going to zip through the limb of Mercury as we head toward Venus. There we go. Goodbye, Mercury. We'll be back. I feel like this is Mr. Rogers' neighborhood. Howdy, neighbor. Bye, neighbor. And off we go. Now to Venus. Very, very hot. Hi, Nancy. Venus is very, very bland with visible light. Now in the ultraviolet light, however, Venus has a different look. Venus actually has incredible structure to its clouds, which is really neat. You can see these chevrons, these amazing shapes that look just like chevrons from like a military rank, you know, that go, you know, through the clouds. It's just incredible. Yeah, so there's not much we could see, but Venus does have a full landscape beneath this cloud cover, and it's modeled in this product, believe it or not. I really like the fact that that's modeled. Modeled, M-O-D-E-L-E-D, modeled. But you know, Venus is pretty much bland to the eye. This image is sort of a blend of the ultraviolet image and the visible light image, because it's really kind of yellow, bland yellow to your eye. This stuff here, these are chevrons that around the planet that you see, these chevron shapes. Very, very thick atmosphere, 90 times thicker than ours. 90 times. Now that means there's a lot of weight in that atmosphere pressing down on you if you're on the surface. At the bottom of our oceans, the pressures can be immense. 9,000 pounds per square inch on your body. On Venus, there's pressures that are similar. It's not that high, but it's well over 900 degrees at the surface. Yeah, I see Daryl's here. Hey, Daryl. Yeah, so really pretty. But now, the next place that's really cool to visit in our solar system is the planet Mars. Oh yes, now Mars is out here for us to check out. It's right there, and we're gonna go flying off to Mars here. You'll notice it even looks a little red here because it's a little bit red. And off we go. Might come in from the back side of the planet so that we can actually look at some really interesting and intricate light as it plays across the planet. Yeah, look at that. See, from the backside, you'll notice that there is a ring around Mars. Now that ring, of course, is due to the atmosphere. Mars has an atmosphere, although very thin. It's only 0.08 times the atmosphere of the Earth. Very, very, very thin. Okay. But this is what Mars would look like from the other side. You wouldn't see a dark disk like we saw at Mercury. We would see the illuminated atmosphere all around the limb here. And that's what we see. Now, why don't we take a little ride. Let's take a ride down here. We'll visit the moons of Mars as well here in a little bit. But let's try. I want to show you some really cool features. Actually, let's do an overview first. We're going to change the NASA rules here and just kind of do a little overview of Mars first from the sunlit side. And this is the correct orientation of Mars right now for what we have. Oh, look at that. Now, see what that is? That is the largest volcano in the solar system right there. That's that's Olympus Mons. This is an amazing volcano, and we're gonna go visit it. Now, if you look, you'll see the lava flows here made these beautiful sinuous rills, and now as we come down, you'll see these scarps here. These scarps all around the edge of Valles Marineris. I'm sorry, I keep calling that of Olympus Mons. They're higher than Mount Everest. They're several miles high. And this here is the crater, the caldera of the volcano. Now, on our Mars mission here, we're going to land here. We're going to come on down and pull ourselves in, and we'll land. Okay. And now, as we land here, we're inside now the caldera. And this is what it would look like to us if we were inside. And let's level our craft, right? and look around. Several miles across. That's how big this caldera is. Very, very large volcano. You know, so it's actually amazing. Now, if you want to see kind of where we are in this whole setup, then we have to add a little thrust here and take off. We'll take off at 30 meters, just about 20 meters per second. Here we go. There we go. Now we're moving up off the surface. Doesn't take much to go up on the Martian surface. Let's kick it up here to get up higher. And now let's kick into a mode where we can actually look down and pull ourselves away a bit. Here we go. That's it. That's the crater of one of the biggest volcanoes in the solar system right there. Olympus Mons. And if you're always wondered what it might be like to see Olympus Mons from the edge of the scarps, we call those scarps, those are those big cliffs at the edge of Olympus Mons here. Those are right there. So let's go look, shall we? Let's go land. Let's take our ship and land it right there. Alright. And let's make sure we don't hit too hard. Okay, let's get down below the atmosphere. Here we go. And we'll move toward Olympus Mons here. Here we go. Nice soft landing. There we go. And we're down. And now as we level our ship, we just rise up a little bit so we can get some forward motion. And you notice that the scarp disappeared because Mars is smaller than the Earth, so it doesn't take a lot of distance to lose something over the horizon on Mars. The Frank Sinatra version of the Gumby song. Oh my gosh. Once he was a little green ball of clay. Gumby. Yeah. I lost sight of my scarp. See, Mars doesn't have a very clear atmosphere. Let's go up in the air. Let's get up. There we go. And it doesn't take long before you see stars when you get into the atmosphere of Mars, when you get up in the air. Because Mars' atmosphere is very thin. Okay, here's another volcano. We're in the Tharsis region of Mars. That's where all the volcanoes are on the surface of the planet. You can see the atmosphere over here on the edge. Alright. Yeah. So now back away a little bit. We'll go to 100 kilometers per second here. Back away. Oh yes. So here's a volcano, there's a volcano. The whole Tharsis region here. And Mars, of course, has craters as well. Lots of them. You know, and it's really amazing to see the many craters of Mars. Huh, it's like dinner in a movie. Well, dinner in Mars. Kind of cool. I like it. Let's just take us down here. Oh, yeah. Now, you might think we're going to crash. But we're not. We're just going to start cruising over the surface. Yeah, there we go. and then to the dark side, the night side of Mars. You'll notice there's dark material that's in some of these craters and on some of the surface of Mars. There's dark underlying material on the surface of Mars, which is really, really quite dark. And as we rise up higher, then we can see some of the other features of Mars that are really quite striking, namely Valles Marineris, this wonderfully long valley which moves across a huge amount of Mars. It's almost like a fifth of Mars is covered by this gigantic valley, which is a volcanic origin, by the way. Back in its early days when it formed, this was a volcanic fissure. Who knows how it came about, but it was really quite a feature on Mars to behold, let me tell you. It still is. Now we have a mission set for Mars, and the idea for the mission is it's going to actually bring a drone to Mars, a helicopter. It's called the Mars 2020 mission. Hi, Marianne. And the Mars 2020 mission is going to bring this drone for the purposes of actually studying Mars from altitude. That's pretty cool, So this is Valles Marineris as seen from what would amount to be several miles. All right. We can't go by this distance here. That's the distance to the center of the planet. Okay, so here we are. Now, if we were to come down, and let's go moving through the valley, and straight down and go right here. Let's go through here, go through this little valley. Doesn't take much. Now Mars is well known for its two moons, Phobos and Deimos. Now, Phobos and Deimos are, in all likelihood, captured asteroids that were captured by Mars. Now, you don't see them here in the view yet because they're so small that they could easily go unnoticed. If you were there, you probably wouldn't see them. This application exaggerates them a little bit and makes them little bright dots, which is unrealistic, but that's okay. It lets you know where they are. Now we're cruising above the atmosphere of Mars here, above Valles Marineris, the largest rift valley in the solar system. And now if we were to pull away now, okay, and let's go back to becoming like a spacecraft, so you can actually see this, how this looks. There you go. Now you can actually see what Valles Marineris actually looks like. Neutrino, the water on Mars went toward doing something very interesting, and there used to be a lot of water on Mars that was free-flowing. That is to say, Mars had a lot of running water. This feature is not water-carved. This is actually geologically made. Okay, but the water on Mars is actually quite evident from studying some of the other landforms and features on Mars. And you might say, where'd the water go? Well, where it went is down into the ground, in part. Because if you notice, the surface of Mars is sort of an orangey red, isn't it? Well, a lot of the oxygen on Mars came from the fact that water molecules were broken up. Water molecules are H2O 2 hydrogen atoms, 1 oxygen atom. Oh, look, you can see some of the clouds on Mars. Mars does have some clouds. And those water molecules, after being broken up, were separated. The hydrogen escaped to space, and oxygen went down into the ground, where it bonded with some of the iron compounds in the crust to form hematite, which is basically rust, right? So it made Mars red. So Mars rusted, in a sense. Kind of interesting factoid there. So it's kind of cool. You know, when we look at Mars, we can see all that. Now, it's in these orange parts here. Again, this is a rift valley here. So Mars had a lot of volcanism going on in its early infancy. Just like every planet. You know, the Earth did. The Moon had volcanoes, in fact. And it turned out that the volcanoes on Mars kind of went dormant after the mantle cooled on Mars. The mantle of Mars is that area just below the crust. Like we have a crust and then we have a mantle. Then we have an outer core and an inner core. And those are separated by other geologic qualities. But on Mars, it lost the magnetic field, which would protect the atmosphere with the water molecules, water vapor, and the oxygen, the free oxygen that was being generated by geologic processes. And so it turns out that Mars, when its magnetic field died, it coincided with the fact that Mars lost its outer core. In other words, it cooled, and the mantle cooled. And when that happened, Mars no longer had a method by which it could generate electrical currents in its core, which in turn created magnetic fields. A magnetic field, and that's why Mars no longer has water running freely, because the atmosphere was deteriorated by the ultraviolet light from the sun. So we're looking at here is a planet in what I would call disrepair. Now, it's possible that we can actually rejuvenate Mars. We can terraform this, Now, Mars does have a lot of water, and that's why I'm flying where I'm going now. This is one of the polar caps on Mars. Now, the polar caps are predominantly carbon dioxide ice, because that's mostly what the atmosphere is. It gets cold enough for carbon dioxide ice to form on Mars, and it gets cold enough for, of course, ice to freeze. And so these polar caps have a significant amount of ice, but the entire polar regions here, all around the polar caps, these areas have a lot of underground ice. Okay, you might have seen the photo of some of the craters on Mars that are filled with ice. Here's one. All right, it's an area. These are areas on Mars where the craters are filled with permanent ice, and basically it's like permafrost. Under the ground here is a lot of ice. So Mars has the potential to be terraformed. How would we do that, though? Well, we'd have to restart the magnetic field, right? Well, and I don't believe any alien civilization has the technology, or would ever have the technology, to restart a planetary magnetic field. They would have to remelt the core. And I don't know about you, but I don't want to play any experimental games with our planet. Do you? So what would we do? Well, there is a way, and to show you that, I have to back away a little while here, a little bit. All right, and let's do that. I'll back away, and let's do this. Let's move down a little bit. Okay, and let's now just take us to an area just about between Mars and the Sun, which is right about, well, not quite yet, but coming right about here. So what happens is, if Mars, this is one of the moons right here, if Mars was to actually be terraformed, we would have to, kind of where the spaceship is, we'd have to put a gigantic generator of a magnetic field Now, it's something we can't do right now, but you see, behind us here, we have the sun. And the sun is generating a lot of radiation that it's sending Mars' way. Okay? And so when it sends this radiation toward Mars, well, one of the problems we have is that this radiation is exceedingly powerful, and the ultraviolet radiation strips Mars' atmosphere of all the vital molecules that it's generating on its own. So what we have to do is we have to figure out a way to protect Mars and let the atmosphere rejuvenate itself, and let the atmosphere grow thicker and get higher pressure. And to do that, if where we're sitting right here in space, we put a gigantic magnetic field generator, then as the sun hits us from our back in this image here, we would end up enveloping Mars all around it and into the distance with a draping magnetic field, like a curtain that would drape over, like a blanket, as Amanda has said. And it would actually make for a really incredible way to terraform Mars without even touching it. Because if we just protect the atmosphere will naturally grow thicker and denser because the molecules wouldn't be destroyed by the sun's radiation. They'd stay there. The atmosphere would get thicker. We'd notice it's working because from the Earth we'd be able to detect it. More clouds. You see a few little clouds on Mars here. We noticed more clouds. And the landers like Curiosity on Mars, the Mars 2020 mission at that point, and others would notice a thicker atmosphere. And we would be now in a position where Mars, within just a few years, maybe just a decade or two, we would see and detect a noticeable difference. So it could actually be something where we could terraform. We could terraform Mars. Now, if the atmosphere is made thicker, Mars, believe it or not, is right at the outer edge of the habitable zone. Mars will always be a colder planet than the Earth, but it can be made habitable. And I think that people would move there. I probably wouldn't. I like scenery, and it's still, there's hundreds of thousands of years before we could see Mars with any kind of human-made improvements to it. But in this one view, it's kind of cool because you see Valles Marineris here. You see Olympus Mons. You also see a moon right here. This moon right here is the moon Phobos. And right here is another moon for Mars, which is Deimos. Okay? And let's go visit Deimos, shall we? Let's go down there. I think that's a cool thing. We'll head on down to Deimos. Okay? So you'll see what it's like to see the view from Deimos, what it sees every day of Mars. Won't that be cool? Here we go. Now we're going to land on Deimos here, so just, strap in and make sure that you have your seatbelts tight against your lap, your shoulder harnesses in place, because as we land, it's going to be a bit bumpy. All right, here we go. So here we go. We see we're approaching Deimos, this little tiny moon. It's a really pretty moon. If a little asteroid can be pretty, but yeah. Here we go. Oops, hey, look out. There we go. My hand slipped on the steering wheel. Yeah. So here we are. Now we're around Deimos right now. And let's just circle it and see what it looks like. And we still have Mars in our view, too. We have Mars in here. Okay. That arrow points to it. Welcome to Deimos. Maybe it'd be beneficial to land on Deimos because we could observe Mars long term. That'd actually be pretty cool. Space is vast. Okay, here comes Mars now. There's the view I want to show you. So you see, Deimos sees this beautiful face of Mars. Now it's circling Mars, so it sees Mars in the daytime, Mars, at night, and it's pretty cool, you know. Now if we land on Deimos, here we are, we're landing on Deimos. Now this is what Deimos sees every day. Wow, of course this is what we would see if we looked at Deimos. On the surface, it's a big enough asteroid so that we have a horizon. You know, really cool. It's 6,700 kilometers in diameter, so that's a pretty big moon. You know, but let's go airborne again here, or should I say spaceborne. Okay, we just punched off of Deimos. Yes, we did. And as we head up into the space around Deimos, we can pull away here. See, you have to get up pretty high before you actually see the sphericity, or kind of oblique sphericity, of Deimos. Okay. But it's just something else, isn't it? Isn't it pretty? So that's what a mission to Deimos would look like. And we can also head on over to Phobos as well. Phobos is an interesting planet. I should say moon. Okay. There it is. Let's head over there, shall we? We'll just circle it. We won't land. So I want to take it to some of the other moons. We still have to go see Jupiter and Saturn and some of the asteroids. Oh man, it's really pretty out there. If not cold. It's cold out there. Kind of like here. Here comes Phobos. Let's go this way so we can get it in the light. It's always tricky to land on these fast-moving objects out here. Okay, we've attained an orbital match. I'm sorry I'm not paying too much attention to the to the chat right now. That's only because I'm focusing on navigating here through the universe. I mean, one false move, and I bounce too close to a star, and that would end your trip real fast, wouldn't it? Movie? Who knows the movie? Oh yeah, look at how Phobos looks against Mars. Isn't that beautiful? Gumby thinks so. Haha. So like silent sentinels, these captured asteroids orbit Mars for eternity. Pretty cool. Very nice. Very nice. And now we leave the Mars system. Let's go to the asteroid Ceres. Alright, it's 3 astronomical units away from us. That's 93 million miles times 3. Alright, now it's just under an AU as of right this second. And it'll come blasting into our view here momentarily. Oh yeah, here it comes. This is Ceres. Ceres is a dwarf planet. Its diameter is 938 kilometers. It's the biggest dwarf planet in the asteroid belt. And if you remember, there was a crater on Ceres called Asteroid crater. Now Ceres does orbit. It does rotate and revolve. So if we didn't catch it where it's on the daylight side, then we won't see it tonight. But Asteroid crater had those wonderful salt mounds that look very bright, because Ceres is actually pretty gray, and because it's so gray, you had to adjust the camera so that you could take the photos of Ceres without overexposing the surface or underexposing the surface. You'd have to make sure that you took these photos at just the right exposure settings. Well, those exposure settings are such that we would actually end up finding a salt mound would appear very bright white, unfortunately. And Ceres has water on it, which is why you see some shine in some of these craters, actually. And that's a real finding. So it does have water. And the Dawn probe visited Vesta and Ceres. Vesta was thought to be very bone dry, and it turned out it was. But Ceres was thought to be actually wet, and it turned out it was. So pretty cool. So if we were in orbit around Ceres, it might look something like this. There you can see some salts. Yeah, Ceres is nice, isn't it, Neutrino? Yeah, it is. Now, in order to take you on a tour that's somewhat nice, I have to, I've had to learn which speeds are the best when you approach a planet. You can't move at outrageous speeds, because then you end up having problems when you approach, So I'm hoping that we won't have those problems by just traveling like this. Oh yeah, this is a beautiful little place to be. Dwarf planet and a universe full of stars. By the way, this application I'm using, this entire universe here, and let's land on Ceres for just a moment, shall we? Let's just land here for a minute. If we landed on Ceres, we might see something like this. This might be how we'd see it. And we wouldn't really know where we're landing. We wouldn't know if it was going to be bumpy or whatever, we wouldn't know. Alright, we're coming down, we're getting close. And we gotta get ourselves down. There we go. Alright. Uh-oh, we landed on a hillside. See, we wouldn't know that either. We might just find ourselves here and think, oh, we missed out on whatever. You know, but we'd look around and we'd see that there's some hills in the distance on Ceres. But I want to show you this. Here's what I want to show you. You look up at the universe. Every one of these stars are correctly placed. Every one of these stars are real. Every one of these stars we can go to in orbit. We can go see planets that have been caught and found around other stars. We can go see what they supposedly look like. We can't actually see what the real ones look like because we can't see the actual planets. We just know they're there. But so this is a really cool universe. And when you get out of our galaxy, even, where's our galaxy? Well, if we keep spinning around, you end up seeing the Milky Way. There it is. Okay, what a view on Ceres, huh? The Milky Way rising on Ceres. That's beautiful. Wow, that's really pretty. You know? Sure enough, that's beautiful. So we raise ourselves up here. And like every other place, you go to the moon, it looks like it's really sharp and has lots of obstructions on it, with very high, sharp peaks here and there. And the fact of the matter is, when you get there, you find it's actually rounded. You know, we're seeing it from a long distance away. So you see how this looks? Well, from a long distance away, okay, as we climb, right, you take a look at how Ceres looks, for instance. All right, once we get high enough, it starts to look like some of these edges are pretty sharp, especially when the shadows are in there. You know, the shadows make them look sharp, but they're not. They're not sharp. You know, they're really not. Yeah. Ceres is full of salt compounds of various salts, and so you see them in the craters. And Acheter crater was not the only one where those are seen. So there we are. This is the asteroid belt with Ceres. Now, obviously, there's a lot more asteroids, and in this application, if we wanted to, we could go view the asteroids and see them in 3D, because we're looking at a very large, an extremely dense, you see, area of stars and so forth, and asteroids in this asteroid field. There's quite a lot. We can also look at the orbits as well. So if we wanted to see orbits of asteroids and so forth, we can. All right. And lots of lines that you have to make heads or tails of. And this doesn't help you much until we go to something like our next destination. Our next destination is Jupiter. So let's go to Jupiter, shall we? Yes, we shall. Jupiter's right over the limb here of Ceres, so we're going to go skirting along. And if you're wondering how I know all these things and how I was able to do this, it's called planning. All right, so now we race down toward Jupiter. Okay, it's 2.47 astronomical units away, as you can see here now, 2.46. And this is the speed of, like, literally half the speed of light. And you'll notice that it's only counting down slowly. So even the speed of light is not fast enough to travel in the universe. It's really not. Wow. Okay, so now we're heading toward Jupiter. Now we're going, let's accelerate faster here. Here we go. Jupiter has so many moons, it's incredible. This is good Jupiter music. You can see the moons moving by us here in various locations as we head toward this massive planet, the most massive planet in our whole solar system. This particular map of Jupiter is actually the correct map for the Juno probe that's circling Jupiter now. The Juno probe has mapped out Jupiter rather extensively, and we were able to see the various locations on Jupiter quite beautifully. Normally the poles, actually. If you look on the bottom here, you can see the Juno map showing you how Jupiter looks from here. Okay, this is the map as Jupiter looks from Juno. Okay, very, very complex, and it's really blue like that too. It's not false color. I'm not sure why, but that's what it looks like. Actually, I know why. It's impurities. And Jupiter has, of course, many moons, many tens of moons, actually. Saturn has more. Saturn's count is up to 80 moons now. So that's kind of interesting. Sorry, there's no up or down in space, so I tend to just let things go where they might, you know. For those who recognize the song, it's the Hall of the Mountain King. Let's go up to the plane of Jupiter's orbit here a little bit more. You'll notice Jupiter had auroras. It does. So let's now check out one of my favorite moons. Now, before you say that it's Europa, it's not Europa. It's little tiny Io. Io's the closest moon to Jupiter, the closest fairly large moon. Okay, the diameter of Io is 3,600 kilometers in size, and it's actually a moon that's being tugged on by Jupiter's massive gravity. And Io is a moon that's actually, it's got a lot of sulfur in its content. Its composition is a lot of sulfur, and so that sulfur is something that has made it really unique. Okay, so as we close in on Io, check it out. you'll see some of the molten sulfur areas on Io. This is real. This is not artificially created. This is real stuff. And you'll notice that Io is predominantly a yellowish orange. There's some black areas too, which is the sulfur as it cools. It turns black. When I was a kid and I was playing with a chemistry set that my parents got me, I got in more trouble with that thing. Oh man, did I! But I actually ended up discovering a lot of things about sulfur. Well, of course, how to make rotten eggs smell. That was kind of fun. That was always a tough one. But here you can see these sulfur volcanoes like this one right here. These are actually really extensive on Io, and Io is being tugged on by Jupiter, and it's squishing like a ball from the gravity that's always tugging at it. So that causes Io to maintain some heat inside because of the fact that it's very, very tortured by Jupiter. So Io's got, a number of things going against it, being that it's so close to Jupiter that it doesn't have a chance. It can't solidify more than it has. You can see the hot spots on Io; those are constant. Now, what happens also at the limb of Io, where these volcanoes are like this, it spouts these giant plumes. Now, these plumes are plumes of molten sulfur that shoot way up into the space around Io. And Io is the closest thing to Hades we kind of really have that's visible. I mean, Venus is, of course, far more Hadean, but Io has going for it the fact that you can see everything, because it doesn't have but a scant atmosphere of just some ions and atoms. But boy, it's really something. Yeah, Io is just one scary place. There's no place on Io that you can go that's safe. Not one place. There it is. You can see some of that black area up here that's like cooled sulfur. And this is Jupiter's closest moon. Now, we all like to go see another one, but you know what? Before we do that, one thing that I didn't do, which I want to do actually, I want to land on Io and show you what Jupiter looks like from Io. Every day, this is what Jupiter will look like on Io, okay? So let's do that. Let's go here and land on Io while looking at Jupiter. So we're going to close in here. Here we go. We'll land here just over the dark side. Yeah. We're on Io, folks. We've landed on Io, and now as we look around, okay, we can see Jupiter looming on the horizon. That's how big Jupiter would be in Io's sky, right there. Its gravity is immense. Its radiation field is stupendous. Its gravitational field is 20 times stronger than our own. And so Io is feeling all this tortuous force from Jupiter. Unbelievable. So that's what it looks like from Io. Now we'll just look around here and see if there's anything worth checking out while we're here on the ground on Io. I know that we tried to land near that sulfur volcano, but I don't know that we got too close to it. Probably not a good idea, because sulfur, molten sulfur is kind of low temperature, but it'll burn you if you touch it. There we go. We'll just pop off the surface. Doesn't take much to get off the surface on Io. All right. So now the next place we want to go is my favorite moon, second favorite, and that's Europa. Europa's an interesting moon because it may have a water ocean. Now, let's head to Europa. We'll go right here. Since Io doesn't have an atmosphere, we don't see things like the stars being affected by reddening or other things that happen here. We're going to go around the sunlit side of Io, and you'll see Europa coming up on the horizon here. There it is out there. And then we have this right here. This is Ganymede, the largest moon in the solar system. We can go there. We can check out Ganymede first. Let's do that. One of the Galilean moons. We have Io, we have Europa, Ganymede, and Callisto. Those are the 4 Galilean moons, the ones that Galileo studied. Indeed. There we go. Whoops. That was a little bit of a error. Let's turn around and go back there. Okay. Alright, so we're back at Ganymede now. Oh no, this is Europa, sorry. We'll go to oh, this is Asteroid. This is the Asteroid Europa. We don't want to be here. I got us in the wrong place. My mistake. Oops. Off we go. I know you want different music sometimes, but this is the music that I can play without getting any kind of copyright strikes. There comes Jupiter again, and here comes Europa. Wham! Europa might have up to a 90-mile deep ocean beneath that crust. That is pretty cool, because we think that if it has an ocean beneath its crust, then perhaps that ocean could potentially harbor some type of life. Now I'm going to come out here and spin around and come back through, so. Now we have to make sure that we stick within the data that we know exists for Europa. We don't have a ton of data for some of the areas in Europa. We have this understanding for Europa. Now it says it's cold and airless, and that's true. It's very cold. Surface is pretty close to absolute zero on the dark side, but it's also being tugged on by Jupiter. Okay, and there's large scarps here of ice, and beneath this is that ocean. It's probably a slushy ocean up near the ice, but then below that it's going to be water. And maybe it'll have some salt. Maybe it'll be a salty ocean. Alright, so if we landed on Europa, okay, then this is what we'd see looking around, depending on where we go. And we are actually going to land in Europa because the Europa Clipper mission is going to find a landing site. And then when we do land on Europa, we're going to start drilling. And we're going to try and drill down into Europa to get an idea of what's going on down there. And this is a good time to tell you about a movie that I really like. It's called the Europa Report. I don't know if any of you have seen it, but if you haven't seen it, oh, is it ever worth it? The Europa Report's a good movie. I won't tell you anything more, but check it out. It's about a mission to Europa. Manned, human mission to Europa. And you'll really like it. Anyway, let's pop off of Europa right here. And let's locate Jupiter relative to us right now. It's easy to lose your bearings, Because Jupiter is right down there on us now. It's below. So we're right on the far side of Europa. Probably the best place to be, radiation-wise. But let's just head out and find it. So we'll go cricking around the perimeter of Europa here. And then we'll see Jupiter rising. There it is. Wow, how beautiful. Yeah. And so, Io, Europa, Ganymede, and Callisto. Now we'll go to Ganymede again. And we'll have visited all the moons that are called the Galilean moons around Jupiter. So now we have to head up here to go to Ganymede again. And off we go. Ganymede is 110,000 miles away and coming closer. Now we're down to just a few thousand kilometers. And here we are. And this is now Ganymede. Ganymede is a really interesting moon because it also seems to have a copious amount of water ice on its surface. Yeah. And who knows, maybe it also has an ocean beneath here. That's pretty cool. Now these are all real imagery, by the way. This isn't artificial, created just for a program. These are real images of the moons and real images of Jupiter and so forth. It's all real data, which I really like. Yep. Yeah. Ganymede is beautiful. And Ganymede does have this modeling on it, which is really weird. It's where ice has melted and refreezed, and it's pretty impressive. Amazing for the size of Jupiter that you can actually be somewhere where Ganymede could completely block Jupiter, and you look around and say, hey, where is everything? There's no Jupiter. But in fact, there is. Yeah. Now the last moon on our trip is Callisto. We won't land on Ganymede. Now Callisto is the outermost of the Galilean moons, and it's way out here. A little dot. Okay. Here we go. Let's head over there, shall we? Now Callisto, again, all the moons of Jupiter, other than Io, all the Galilean moons, other than Io, are icy. So we're looking at it in the same way. But Callisto, look at how beautiful Callisto is. It almost looks like an exoplanet you might find in a science fiction show. There's some rich greens here. There's browns. It's really impressive. Lots of strange, well, what you call it, impurities, I guess. You can see rings here where ice was fractured and refrozen from an impact here that was absorbed, and then the liquid leveled out the surface. And when you don't see a lot of craters, it means that the surface is being regenerated and refrozen and rebuilt. That's how that Sputnik planum on Pluto is. That's that plane, and it has no craters whatsoever, yet Pluto is littered with craters other ways in other places. But this is Callisto. Look at those beautiful greens, huh? Gumby's still smiling, so I guess he likes it. Now, what would it look like to see Jupiter from Callisto? Well, there we go. I mean, that's what Jupiter looks like. So it's really not that far away, is it? Yeah, that's something. But imagine the dramatic views that you'd get, okay? For instance, let's spin around. Now look at this. What a dramatic view, huh? Jupiter rise. That's impressive. That's pretty cool. We had an Earth rise on the Earth, remember, with the lunar pilots when they were coming around the limb of the moon. Now we have a Jupiter rise. Really beautiful. Really pretty. Well, I think now we should travel on to meet Saturn, don't you think? Yeah. Now Saturn is literally from us at Jupiter. It's another 5 astronomical units away. Okay. So more than twice Mars' distance. And thus it's a little tiny pinpoint of light like the stars. But let's go. The colors are beautiful, Nancy, I know. Yep. Oh, I'm sorry, Carol. You should be a moderator. And here we have Saturn. You know, a lot of people, when I was a kid, I thought that Saturn's rings were actually solid. But obviously, that was silly. But, you know, I didn't know any better. And you can see some of Saturn's moons here. Okay, this one right here. If I can grab it. Yeah. Okay, this is Tethys. Let's go check out Tethys. It's a tiny moon. It's only 1,000 kilometers across. You know. By the way, you can see the shadow of the rings here on Saturn. That's a shadow of the rings. And that actually is pretty prominent. You can see that from the Earth in the telescope. When Saturn's at the right angle. I'm trying to line this up here. There we go. Yeah, see, we're approaching Tethys now. It's about 30,000 kilometers away. You can see how Tethys was tortured. Amazing, isn't it? Look at that. What an amazing moon. The data that shows us Tethys comes from the Voyager and Cassini missions. It's really just an amazing thing. But look what Tethys sees every day. Look at that. Just incredible. Oh, we're gonna see Pluto, but you can't deny this is beautiful. You know? So we're gonna leave Tethys behind here. Sit by Tethys and then go up through the rings. It's almost like we're on a cosmic racetrack. It's amazing, isn't it? Now we're in the shadow. Let's go through. Cassini did this too. Cassini went through the rings and it didn't hit a single thing. They weren't sure, but the Cassini mission was a very successful mission, and it went right through the rings of Saturn. Yep. Indeed. You can see how the rings are so gossamer in some places. Well, let's pull away for a minute from Saturn. The data that you see on Saturn is from Cassini. This is the view we see from Earth. But how about the view we don't see from Earth? How about the view we would see if we were at a different place? Like right here. Now, here you see several of the moons. They're all glowing here. But look, you actually see the shadow. This is something we don't see from Earth. The shadow of Saturn on the rings. Isn't that incredible? Indeed, it's beautiful. Yeah, it's a beautiful system. And then there's something else to look at on Saturn, which is it was very popular and talked about quite a bit in the news, and that was at the North Pole of Saturn here. We actually had this hexagonal shape. You notice that? This hexagon is a mystery. We think it's probably something that's related to a resonance of the moon. Of Saturn with the atmosphere. You know, the cloud bands within the atmosphere. But that's an interesting hexagon. 1, 2, 3, 4, 5, 6. See, 6 sides. A resonant feature of Saturn's atmosphere. Pretty cool. Then we're on the dark side of Saturn. So what'd you think of that? Wasn't that beautiful? Flying through Saturn's rings and spending time in the Saturnian system. But that music means it's now time for us to move on. And we'll move on via one more visit here in the Saturn system. We're going to go visit Enceladus. Enceladus is the other moon in this location where around Saturn, where we actually think that there might be an ocean underneath its icy mantle as well. And this ocean could harbor some life, who knows? Here you see the Pleiades out here. We can see the blue reflection nebula around it. You can also see the Hyades. This is red Aldebaran. Oh yeah. And now we're here coming into Enceladus. Tiny Enceladus is only 310 miles across. But Enceladus is actually harboring an ocean under its crust as well. And at its south pole, it's spewing geysers of icy water. And these ice water geysers are also spewing hydrocarbons and hydrocarbon compounds, which are, as we know, the building blocks of life. So it seems that no matter where we look in our universe, in our solar system anyway, we're catching life. Now you'll notice that it looks like it has light from three sides. Actually, lack of light here, and then the sunlight here. This is what it lives with, Enceladus, because it's so close to Saturn. Okay, Enceladus is going to be illuminated by Saturn itself. And so that's why Enceladus, tiny Enceladus, has this illumination on it like this. That is pretty cool, you know. So if we were going to do a mission to Enceladus, well, then we'd probably wouldn't matter if we went to the Saturn-lit side or the Sun-lit side. The Saturn-lit side is actually pretty bright. Okay, this is scale brightness here. So this is pretty cool, you know. Yeah, and I'm telling you, it's just a absolutely beautiful moon. Beautiful in its tortured, sinewy structure. It's just so odd-shaped. You can see places where the moon has been torn apart and flexed. And these flexing areas are homes for those geysers too, the fissures. So it's actually quite an interesting moon. You'll notice that there's some areas that are flat, some areas that are cratered. These cratered areas are older than the areas that are not cratered, because the cratered areas are areas that have lasted for a period of time. The uncratered areas are areas where the ice was melted and then refroze due to some geologic process, and that's kind of par for the course, you know. We head further away from the sun as we head out to Uranus, and Uranus is actually is from this point of view. You'll notice where Uranus is relative to Enceladus. Okay, and you'll see that Uranus is right there below the Pleiades, and we're going to head there. So we're going to leave behind the Saturn system for now and go off to Uranus. All right, so here we go. Off we go. Okay, we're under an AU from Uranus now. Uranus is sort of a bluish teal color, and it's fairly uniform in its color. It does have some complexities to it, but it's actually fairly straightforward. You'll also notice the rings. Uranus does have a ring system that is comparable to ring systems around other planets. We were at Jupiter, and Jupiter had a ring system as well, but it was very, very hard to see it, so I didn't call it out. But it's a very, very faint ring with carbon particles that are very dark. But it seems like the giant planets all seem to have rings. And Earth had a ring too. Did you know that? Earth had a ring early on, and that ring was made by the particles that eventually made up the moon, because there was a collision with the Earth and a large Mars-sized body that squirted off the moon when it made Earth molten again. And that collision spawned the moon and billions upon billions of debris particles and asteroids. And those ended up forming a ring around the Earth that continued to pelt the Earth for a long time, millions of years. And we ended up having another bombardment area as a result of that caused a lot of the craters that are on the moon now. It's just amazing, you know. So if we look at Uranus here, we can actually look at the solar system at a glance here. And if we go to Uranus and take a look at the moons, we can see that we have Miranda, Ariel, Umbriel, Titania, and Oberon. And let's take a look. Now, if you look here, Oberon is 1,523 kilometers in diameter, but the biggest one is Titania at 1,578 kilometers. So let's go to Titania, shall we? Okay, and we can dispense with this here for now and just head over to Titania. Titania sits fairly far away from Uranus. And as we approach it, okay, we'll notice a very interesting set of features on it. It's really cool looking. Donald, that's funny. I remember that song. You know, there's Klingons on the starboard bow. Scrape them off, Jim. Yeah, you notice, you'll see Titania has this really interesting set of geological rifts and tortured highlands here. And that's due to the fact that some kind of cataclysm struck this part of the solar system. And Uranus, was knocked on its side. It orbits exactly the opposite, of Earth. It's 90 degrees out of phase with Earth. And the reason it orbits like that, it has that orbital structure, is only theorized. We don't know exactly why, but it had to be some kind of accident in the early solar system. Now, like Saturn, at Saturn, Uranus will also illuminate the dark side of Titania at times. And you see it right there. And if we go bring up Titania again, okay. It's a fascinating place. So you can see how far away Titania is. And you can see the other moons. If we turn on the orbits, you can see the complex structure of the orbits for the moons around Uranus. We're going to visit Oberon now. We'll turn off the orbits. You'll see next to Titania, relatively close by, is Oberon. Very interesting. And as I said, Oberon is 1,520 kilometers in diameter. I almost said miles, yes. I'm going to go past it and then turn around and come back so you can see the panorama. Look at that. Isn't that beautiful? So far out in our solar system, guys, far out in our solar system, we have this vista playing out every single day. It's stunning. So if we were to land right here on Oberon, what do you think of this, huh? Let's move up the slope a little bit though, huh? As we move up the slope, now there's a view, huh? Uranus rising. And you can see that there is detail to Uranus's clouds, the cloud deck on Uranus. Yeah, we're on Oberon here. This moon is Oberon that we're on. Yeah, Donald, Callisto was beautiful, wasn't it? With some greens and browns. Oh, and that's real stuff. Look at that. So here you are, folks. We actually, landed on Uranus's moon Oberon and saw what it looks like from here. Uranus is beautiful. Beautiful blue sentinel in the night sky. Really, really stunning. Really stunning. And then, even further away from us is Neptune. And it's quite a distance from Uranus. It's 21 astronomical units from us at Uranus. Way out there. That's where Neptune is. So we'll say goodbye to the Uranus system and head back and out to Neptune. 10 AU, 8 AU, 5 AU, and then finally 1 astronomical unit away. And then finally, Neptune. And we're here. There it is. Beautiful. Absolutely stunning. Okay, so now, if we look at Neptune, Neptune has more than 2 moons, but the king of the moons in the Neptune system is Triton. So let's go look at Triton, shall we? If we look at the orbits, you'll see that there are more than just the 2 moons that are suggested here. There's a number of smaller ones like Galatea and others. But let's go to Triton. Triton is very interesting. The reason Triton is interesting is because Triton has an atmosphere. It's a fascinating little moon. I'll tell you all about it. As we get closer to Triton, you can actually see the line of Neptune's rings there. Okay, and then backlit by Neptune, you can actually see Triton's atmosphere, which is why we approach from this side. All right. So, oh yeah, so now what happens here on Triton is really interesting. Triton's surface is made of mostly nitrogen ices, and just like with Pluto, these surfaces sometimes sublimate and they leave nitrogen in the atmosphere, and this nitrogen forms a very, very faint, very tenuous atmosphere around Titan. I'm sorry, around Triton, not Titan. We did not go to Titan, by the way, in Saturn, but that's for another day. There's a lot to look at Titan. So Triton here at Neptune has this amazing little atmosphere, and you can see so much, you know, as you go zipping by it. You know, and we come around here, and now it's bathed in the blue light of Neptune. Incredible. See that? How beautiful is Triton, huh? And as I said, all these maps are maps that were based on data from NASA, not some type of made-up stuff. This is all, the real scientific data as much as we know. Okay. So now, what you've all been waiting for is Pluto. Now, Pluto is another 29 28.8, almost 30 more astronomical units away from the sun. So this is just incredible. All right, so now let's go to Pluto. Now Pluto is interesting because it has 5 moons of its own. All right, it has Charon, which you know is the bigger moon. It has, well, actually we can look, see. It has Charon, it has Styx, it has Nix, Kerberos, and Hydra. Now you'll see that it looks fuzzy here because we didn't get high resolution imagery for this part of Pluto. So we only have this part. So imagine, we don't even know all of Pluto. Me and my Pluto. And you'll also notice as we come around the limb of Pluto that just like with Triton, Pluto has this tenuous atmosphere as well. See that? Yes, it does. It has a nitrogen atmosphere just like Triton. And what's interesting about Pluto is it has this red surface material, an impurity, and then it has these white areas which are nitrogen ices. But, and we can just barely see it here, the surface of Pluto, this is Sputnik Planum here, the surface of Pluto is also an amazing location because of the fact that Pluto is being resurfaced. This area is new material, relatively, and it's come up because of the fact that we know that these craters were deposited a long time ago, but this material is showing us that Pluto has resurfaced itself multiple times in the near past. Look at it. It stands out like a sore thumb. Okay? Sputnik Planum stands out like a sore thumb. Here's the highlands. These are older materials. This is new material. It's being resurfaced. Isn't this crazy? This is Pluto. Pluto has a really strange geology going on here. Now there's the Pleiades setting on Pluto. That's pretty cool. And as we get down lower, you can start to see the haze of the nitrogen atmosphere on Pluto. Pretty cool, huh? And the other thing is you can actually see these squared off areas where it refroze here on Pluto. Really incredible. You know. Yep. In our 3D prints of Pluto, we actually have we show a lot of this detail. Yeah, it's really something. But Pluto is a frigid, cold world. The temperature is really fairly close to absolute zero, and it's really not a hospitable place. The World Guy, discovered in 1930 by Clyde Tombaugh. That's right, at Lowell. I was just at Lowell a couple weeks ago, and I actually I sat. And I've told you guys this story. I think I sat with Clyde Tombaugh on a grassy hill in Vermont, where we were attending an astronomy conference, and I was talking to Clyde for a while, and he was such a nice man. I mean, he was just so self-deprecating. He didn't think of himself as anything other than an astronomer, And I think that's where I took my lessons in how to be, humble or whatever you want to call it. When I saw Clyde, for all that he had done, he just sort of like, oh, it's no big deal. It's like, oh my gosh, I guess you leave it to others to say what a big deal it was to find this. But he found it. And I thought that he was really quite an amazing man. I felt bad when he passed away. I might actually have shed a little tear because the guy was just the nicest man on earth. So as we back away now from Pluto, all is not finished with the Plutonian system, because we do have, and you can see that layer of nitrogen there. Actually, it bears repeating. It bears a little visit. Let's just head back there for a second, shall we? Okay. You can see now. There we go. Stunning. And there we see the beautiful landscape of Pluto. All right. Yeah, we're not done with the Pluto system. We're going to head out to the Kuiper belt as well. Indeed. You can see where this is an artifact. The data ended here. Now what's interesting is Charon is not even far away, but in all of our turning and motions we haven't seen it, have we? Yet it's here as we turn away from Pluto, and there it is. Well, I hadn't seen it anyway. I don't know if any of you saw it. But Charon is really interesting because it is very interesting, I said, because one thing you'll notice about Charon is that it has the same red material. But the red material is deposited at its poles, which is really interesting because this is material that was actually brought from Pluto, which is really one of those things that you just you can't fathom. But their common center of rotation, their barycenter around which they rotate together, a material that gets spewed off of Pluto makes its way to Charon, and it ends up getting deposited right here. So there is a common rotation barycenter kind of in between them where this happens, and I was just placing us so that we can see Pluto and Charon. This is scale distance. Okay, Pluto's a dwarf planet, Charon's a small moon. In fact, Charon is 1,800, what's the diameter? 1,200 kilometers in diameter. It's really small. Isn't that something? Now, what I think we should do, which I'd always love to do, is I would like to land on Pluto. I'm sorry, Charon. Okay, so this is a surface of Charon might look, how it might look. You can see the hills. Charon is a fairly bumpy location. Has some bumps to it, no doubt. But if we can just pop up a little and then get high enough where we can get Pluto back in the view. still have to go up higher. Well, I can go this way. Let's go. Let's start moving. So we zip over the surface of Charon, and then we can actually see Pluto rise. Isn't that incredible? Yeah, that's really pretty. So that's what Charon sees every day. California dreaming. So good to see you. These pictures come from the New Horizons spacecraft. This doesn't. This stuff here, this is just surface material that's been faked up for the Charon moon. But the images of Charon when you get farther away are actual from New Horizons. And this is too. California, I owe you a call. I will. Lots happened. Now you notice, by the way, how shiny the surface is right here. That's because this particular moon is covered with nitrogen ices as well. It has rock as well, but there's a lot of nitrogen ices as well, just like on Pluto. So we see this little bit of shine. The application is quite accurate, and I'm very impressed with it. Now this isn't accurate here. This is just, you see like these linear lines. You wouldn't see that, of course. But it's an approximation of the Charon system. But if we move up higher, okay, then you can actually see what it might look like. And we can back away. Oh, yes. God, it's beautiful. It's so beautiful. By the way, I want to take a moment to thank all of you for joining me on SkyTour LiveStream tonight. This is on our alternative view. And I don't take myself too seriously, as you can see with Gumby down here in the corner. But I just really find this to be amazing. So now what I'd like to do is take us out into the Kuiper belt for the final stop on our solar system tour. We've hit every single planet and some of the moons. Yeah, Daryl was in the chat. He was supposed to join me tonight, but he never. I think he wanted to stand down tonight because it wasn't doing real astronomy. We were doing this imagery, this CG stuff. But I mean, it's real imagery. It's from the New Horizons spacecraft, so it's really gorgeous. And I just love it. You can't imagine how long I've spent just doing what I'm doing now for you guys. Just incredible. So there's the Pluto-Charon system, and I know it looks like Charon's bigger, but it's not. We're just closer. Okay, so if we move away, okay, now you can see that we're moving closer to Pluto, and Pluto is, again, a lot bigger than Charon. And the dwarf planet Eris is out there in the Kuiper Belt, which is where we're going to go. Okay, so Eris is up here. So let's head out 102 astronomical units, shall we? And go to Eris. And leave Pluto behind. Pluto won't even be remotely visible from Eris. So this is Eris, and you'll notice it looks markedly different from some of the other moons we're looking at. And that's because we don't really even know what it looks like. We've only detected it that far out in the Kuiper Belt. We don't really know what things look like, frankly. However, let's just take a look at what the sun looks like from out here. That's the takeaway here. There's the beautiful Milky Way. Oh, the Milky Way is certainly beautiful out there for sure. As we move by, there's our sun. And Eris eclipses the sun. We're out as far as any of the probes. I mean, New Horizons made it out past Ultima Thule after reaching Pluto. Voyager, of course, is at the heliopause and beyond, and that's the area where the influence of the sun is mixed with the interstellar medium influences, and so we don't have too much that we can say is happening out there that we can, call the sun's doing. But one thing that's interesting that I've told you before that you might remember is that in our solar system we have this Kuiper Belt, and then we have this Oort cloud, the cloud of comets way out there. And the Kuiper Belt and the Oort cloud, actually, turns out it may extend all the way to 3/4 of the distance to Alpha Centauri. Now that's incredible, but that's one of the models that has been put forth, and it could be correct. So perhaps some of the objects that are in our solar system right now, as we drift back away from Eris and head out of our solar system, perhaps some of these objects are objects from a different solar system. We know that's possible. We know that's happened. Oumuamua, this comet, this interstellar comet that's joining us. Okay? And as Eris eclipses our sun for one last time, I'm trying to get just at the edge. There we go. And then we say goodbye to our solar system and good night. Our sun will become a point of light. Just a short moment here. Another point of light. And I know it doesn't look like we're moving. But look at the sun receding into the distance. I'll take us to one more place because it's kind of fun. If I could find it. No, I don't want to go. I don't want to take us to the black hole. Well, you know, why not? Want to go see the black hole in the middle of our galaxy? I think you would probably like this. This isn't ours, actually. We want to go to our black hole, which is called Sagittarius A. All right. Yeah, that's quite a ways off. And that's Sagittarius A is 28,000 light years away. It's the black hole in the center of our galaxy. And I got to steer carefully around it because it's extremely bright, has a lot of energetic radiation. Well, you'll see what I mean when we go there. So watch carefully now as we head here, okay? I'm going to start taking us there, and I'm going to increase speed. And now the stars are going by. Okay. There we go. And we're still 22,000 light years away. But you can see some of this dust and this beautiful black dust in our galaxy that makes the dark lanes in our galaxy. It's almost like rain, stellar rain. Okay, I made a little mistake, but it's kind of good because I'll bring us there in a minute. I just want you to see now that we made a mistake, this is all the known galaxies in the universe right here. We're among them. Look at this. This is an actual map. It's truly a map. Now we're moving those. Everything you see are not stars. Those are galaxies. Billions and billions of galaxies all around you. Until we come back to our little place in the cosmos. The Milky Way. And there we are. In the middle of our Milky Way, there is a massive black hole. Now, as we get closer to the Milky Way, you'll start to see some of the stars come out to greet us. Those are all galaxies you're seeing. We haven't seen stars yet. Now we're going to see stars as we enter our galaxy. Okay, so we're going to come down here. You'll see some of the stars pass us as we get closer to the disk. Okay, they're going to come up. There's one right there. It's going up. That's a star. All right, and now you'll see more. There we go. Isn't that amazing? And we see lots of the dark nebula in our galaxy here. Occasionally we'll see some interesting objects that go by us. We'll explore those another time. There goes one. There goes another. And then as we head up above our disk one more time, you see some amazing views of our galaxy from as it recedes behind us. But you know what we'll do now? And we're still going to go to our central black hole. But first, I'm going to take us to one of the globular clusters. Yes, Messier 13, a globular cluster that we've actually seen in SkyTour LiveStream quite a bit. Okay, and let's go there. Let's go here and there. Why is it not? Oh, I know why. Sorry, I was mistaken in the way I was putting it. You gotta put a space for this. There we go. Now, M13, sorry. Okay. So you see some galactic clusters, like this one here. Yeah, that's not a globular, but it is a galactic cluster that we're zipping through. And now, let's find our way to Messier 13. Wow. See, this is cool. So, I told you, it's a universe in 3D. And there we go. We have this beautiful view. Let's go right through the middle. What do you say? Want to do that? Let's do that. Now, what if we were in the middle here? What if we were on a planet around one of these stars in here? Outrageous. Amazing. And those globular clusters, like I've told you a few times in the past, they're halo objects. They're objects that are around the outside of our galaxy that every now and then will cross the disk of the galaxy and maybe deposit some stars, maybe pick some up. And they're among the oldest stars in the galaxy and in the universe, because we find that these globular clusters exist in all the galaxies we see. Okay, now, as promised, let's go to Sagittarius A. And here we are. Let's do this. Let's just go into this mode here. It's very, very high energy location here. There's a number of stars. You can actually see a number of stars here that are orbiting and maybe even being absorbed by Sagittarius A. Hard to believe that things like this exist, but we've seen them. We've seen them. We have visual confirmation of Sagittarius A. And we also have seen, M87, 55 million light years away, shows the very same thing. interesting thing is we pull away, you'll see some stars. These are the actual stars that have been mapped over the 10-year study, showing the stars rotating around the center of our galaxy. And these are the stars that are, one by one, perhaps being eaten by the black hole, which is right there in the center of the cross, center of our galaxy. It's an amazing location that would be deadly for any life forms in this galaxy. Isn't that amazing? I want to take you closer to the black hole now, because we have to get close enough to actually see how the black hole warps the fabric of space. Now, this is going to be tough. Let's see if we can do this. Ejected from the black hole. All right, we're gonna do this right. We'll get there. We will get there. Yes, this black hole is hungry. Oh. Back and forth, back and forth. Hey, we're getting there. Ay, ay, ay. Okay, one more time. Okay. Dinner music for black holes, you know. Want some wine with that black hole, ma'am? White or red? We have this beautiful drink for you, this beautiful wine that I think would go very well with the vision for tonight. Tonight's black hole brought to you by Tim Tams. Chocolate biscuits from Australia. There's a reason I'm doing this, guys. I want you to see. Come on. I want you to be able to see the amazing amazing warpage from the black hole. Let me see if I can do it now. I know it's a white screen. We're in the middle of all this high radiation here. So let's do this. Because when we get into the event horizon, everything goes black. Nope, that's not what I wanted. I want my Sagittarius A black hole. There we go. And there it is. Okay, so let's try to get this to work. 6 AU. All right. 3 AU, 2 AU. Approaching. Under 1 AU. Ah, here we go. Ah, ha ha. Now let's see if we can catch this. We're seeing the interior of the black hole, but there's something else that's visible. Oh, not that. Oh, look at we're seeing warpage. That's it. We're getting warpage. That's what we want. We want to see the actual gravitational warpage, which is what we're checking out here. There we go. Ta-da! So here, you actually see the warped image of the universe. This is exactly what you'd see. Einstein predicted this kind of view. And we actually do see that. Notice how everything goes the opposite way you think it's going to go. Look at that. That's cool. Nothing inside of here can get out. We're just seeing the light that's got in here and not light that's ever going to get out. We're light and we're circulating in here. We'll never get out of here. So, there it is, Sagittarius A. And now we're actually now trapped inside the black hole. And will we get out? Maybe. But I don't think so. We're trapped inside. So we're going to have to go outside the black hole using our application to get us there. Anyway, so we actually explored the entire solar system. Then we explored the Kuiper belt, outside the Kuiper belt a little bit. And then we came all the way out to Sagittarius A. And there's an awful lot of other really interesting stuff to see in our galaxy. And it's really kind of fun to just go tooling through our galaxy. And I really love it. These are real objects. And in the next session, or the next cloudy night session, what we'll do is we'll go to some of the objects that we look at in the telescope and see how they look in 3D. But that's for another time. That right there is the Carina Nebula. A little sneak preview. Okay, we can look at it right there. Hey. Yep. It's like tears in the rain. Oh yeah. How beautiful. I've seen things you people wouldn't believe. Attack ships on fire off the shoulder of Orion. I watched sea beams glitter in the dark near the Tannhauser Gate. All those moments will be lost in time, like tears in the rain. Time to die. One of the most famous lines from a movie, Rutger Hauer in Blade Runner. Well, I want to thank you guys for coming along for this little ride. I'm really pleased that you came with us. It's time to go back to reality here. We're gonna go diving down into our galaxy now. Head back to a little nondescript blue marble, pale blue dot, around 20,000 light years away from the middle. We're a little bit closer to the center of the galaxy, as it turns out. Yeah. And here we are. We're home. So yeah, I got you home safely. Yeah. Now, I don't know where everybody is. It's a big planet, but not as big as the universe, as you noticed. Alright. There's India, Sri Lanka, Saudi Arabia, the Red Sea. Spain, the Mediterranean, the Atlantic, dark. And the United States. I live right here in Connecticut, which is really terrible for astronomy. But I'm moving here to Arizona. And that's where the observatory, of course, is going to be. Yep. So, all that said, I want to take this moment to share with you that I had a really wonderful time doing this with you. I hope you guys enjoyed it. If you like it, give me a thumbs up. Don't forget about our GoFundMe page for the observatory. If you're of a mind and you wish to donate to getting our observatory out there, you can. It's a sort of a community project, but I think you know my dedication to it and to you. I will certainly never disappoint. But I would like to ask you, if you have any questions or comments, please do send me an email at skytourradio@kgraradio.com. skytourradio@kgraradio.com. That's kgraradio.com. All right, and I think perhaps we'll leave it at that. So you guys have a good evening. I'm going to head upstairs, probably go to bed. It's 2 hours, 45 minutes, and 15 seconds we've been streaming. And it feels like I just started. So I have to cut it at some point, or I'll just not stop. All right? Is that right, Gumby? Yes, Mr. Guy. Yes, okay, well, yes. Gumby says so. Anyway, I hope you guys will pardon me for bidding you adieu for now. I really enjoyed your company. I'm sorry I couldn't pay as much attention to the chat this time around, because my hands are quite full making sure that all the navigation was working right. It's not easy to fly a spaceship through the cosmos and skim planets and go in and out of craters and stuff. It's not quite that easy. But I enjoyed doing that. I used to do it up at the studio, actually, with Doug Trumbull, because we had a Digistar system up there, which is a very, very high-end planetarium system. And he would have people up, producers or other people, and he would ask me to take them on a tour of the universe. I was like, oh, okay. So I would go ahead and get a joystick and go racing through. I don't have a joystick here. I'm doing keyboard and mouse for all this, but and so I got pretty good at steering us around using these kinds of applications. And your 3D spatial orientations and all, understanding where the 3D spatial setups, all very important. So that's where I got all that experience. Anyway, you guys have a good evening. I'm gonna be out of here. This is Mark D'Antonio with SkyTour LiveStream signing off for now. We have a big snowstorm coming, so I had to do maintenance on a tractor today. We have one of the hydraulic hoses popped, and so we have to change a hose probably tomorrow. And so it's going to be kind of a miserable day. But anyway, this was all for you. Thank you guys for coming, and I will see you on the next SkyTour LiveStream. And remember, keep looking up, guys. Good night.